Assalamualaikum warahmatullahi wabarakatuh and selamat sejahtera. So in this video we discuss question number 14 and question number 15. So hopefully you guys tried it beforehand. Okay, we start with question 14 first. So I will highlight it for you. An object is dropped so that it continue free form motion. Find acceleration, displacement, velocity and time. So just write down the important information from the question. So A, they want you to find acceleration, B, displacement, S, velocity, V, and then time. And then the last one is time as well. The keyword here is that an object is dropped, which means that the U is equals to 0. So we can draw a simple diagram. You can imagine maybe this one is a stone or something. Find its acceleration. So for an object that moves in a free fall, the acceleration will always be equals to 9.81, which is due to gravitational acceleration. We can write this one as downward. Equation B, displacement after 3 seconds. So after 3 seconds, this object already moved. So time is equals to 3 seconds. So they want you to find the displacement, the length or the distance it travel between those period. Again, it still falls under the gravity. So acceleration is 9.81. I'm gonna take this formula here and I'm gonna replace this one, the A, I'm gonna replace with G. This one is a free fall cases. Okay. Alright. So what I'm gonna do is that I'm gonna put negative and G, replace A with G. Okay, now the displacement after 3 seconds, I think you can use either second or third equation, but they did give you the time, so I think you can use the last one. So S is equals to UT minus half GT square. Okay, UT becomes 0 because U is 0. So you have negative half 9.81 T square, 3 seconds. Don't forget to put the square. Okay, notice that I didn't put the negative inside. Oops, negative inside here. The negative is on the outside because you already put the negative in the equation, or else it becomes redundant. So I got here is negative 44.15. So the negative here means that the displacement is actually below the starting position. So I told you previously, the starting position will be S equals to 0. Anything above means this one is positive S. Anything below means that this one is negative S. So the negative here indicates that it is below the starting point. And don't forget to put the unit. Okay, that one is for B. C. Now we're going to do C. Its velocity when it has fallen 70 meters. So now, as it's given, but they want you to find the velocity. Again, you have to choose the formula. If you want to find V, you need to use either first or second one, because the third one doesn't have any V inside there. You don't know the time, but you do know the displacement, so I think we can use this one. So it will be V square equals to U square minus 2GS. We're still dealing the same situation where U is equals to 0. I can take the square root, negative 2, 9.81. The S would be negative 70. Don't forget, this is a square root. Okay, why do you have to substitute negative? Because again, is because that the position is below the starting position. So the 70 would be down here, right? So you should put negative 70. Okay, so press the calculator. The square root I got here is 37.06 ms minus 1. Okay, that one is for question C. Now moving on to next question. Okay, again, if this one is your exam, make sure you do in a new page. Okay, question D. The time for it to achieve a velocity of 25 meter per second. So they want you to find time if they say that the final velocity is equals to 25 meter per second. Okay, so here you can use the first equation where v equals to u minus gt. U is still 0. And now you want to find the time when the v is negative 25. Why do you have to substitute negative? Because this one is pointing downwards. Here 2.55 second. Right, E, the time it has taken to fall 300 meter. Now they want you to find time when S is equals to negative 300 meter. I think this one I can substitute negative in advance so that you don't forget about it. Okay, negative 300. You can use the third equation to get the answer straight away because you are given S and you want to find T. So S equals to UT minus half GT square, where S is negative 300, UT is still 0, because U is still 0, 9.81, and then don't forget to put the square. Negative cancel out. So you will have 300 multiplied by 2 divided by 9.81 and take the square root. Here's 7.82. Don't forget the unit. Okay, so double check the answer. So I got okay. Okay, the final answer seems correct. So I think everything should be okay. Okay, now moving on to the next question, which is question 15. A rocket is launched upward from the ground with the initial velocity of 35. So I'm going to draw on this diagram. So in exam, please redraw the diagram. But here, since this one is here, u is equals to 35 meter per second. Okay, the magnitude of its acceleration. So initially it has an acceleration 5 meter per second square. Suddenly the engine breaks down at a height of 20 kilo. Okay, so let's say this one is 20 km. This is the displacement when it undergoes acceleration of 5 meter per second square. And then neglect a resistance, calculate the speed of the rocket at the height here. Okay, so this one is the first question, V1. I just put V1 here. The maximum height achieved by the rocket. So the maximum height is here, the total height. Okay, so in this diagram, they already put symbols, a different symbol. This is the height, this is the height prime. So between 0 to this position, between the ground and this position, it undergoes acceleration of 5 meter per second square. After that, the engine breaks down, so basically the rocket will undergo acceleration of negative 9.81, which is the gravitational acceleration. And the last one, the question asks you to find the time of the flight. Okay, I think it should be okay. Quite straightforward as well. So we start with A. Speed of the rocket at the height of 20 kilometers. Again, I'm going to copy this one. Okay. You can do the same in your exam. You can copy down from your formula sheet so that you can see clearly which equation you want to use. Okay, if you want to find the V, I put that as V1. You can use, you know the displacement as, you know the acceleration, and you can find the V using the second equation. Okay, during this period, remember the acceleration is equals to 5 meter second square. So U square is equals to 35 plus 2, 5. Okay, change this one to meter because you know everything else is in SI unit. Okay, don't forget to take the square root. I got here V1 is equals to 448.58 meter per second. Okay, you can write down up until 2 decimal place. Okay, that one is over here. So we already have the values of V1. Okay, now you want to find the maximum height achieved by the rocket. Okay, you can find the maximum height because you know that here in this position V is equals to 0. I put this one as V2. Okay, and my V1 now becomes U2. Understand that? Because now we just want to consider this part. So obviously this part has acceleration and this one undergoes a free fall. Okay, so we do it separately. So once you get the height, you just have to multiply. Sorry, you have to add up lah. Okay, B. You can use the same three formula, except you can change this one to G. You do have the initial velocity and final velocity. You just want to find the displacement. You don't have any time, so you can use the second equation. So final V square. Okay, I'm gonna write the formula first. Okay. So I'm gonna replace this one with the symbols that we use. So this is your V2, which is equals to 0. Okay, and this is your U2, which is 448.58. And because this is a free fall, I'm gonna replace this one with G and the S with the H prime. Okay, so this is just change of the symbols. I'll show you so that you don't get confused. Okay, V square is equals to 0. 448.58 square is positive because it is pointing upwards. Minus 2, 9.81, and now you can find the H prime. Okay, so you will have 448.58 square and divided by 2 and 9.81. You should get 10.256.07 meter. Okay, so this is your H prime. So your H max is basically, this is your H max is basically this height add up with that height. So this height is 20 kilometer. Okay, and then this is the one that you just calculate so that you can get this one. Okay, I think should be okay. Good. As long as you draw, you should understand this kind of question. So H plus H prime becomes 20 kilo, change to meter. Okay, I got here is 30,256.07 meter. This is the distance from the ground. So when you measure the height, always measure from the ground. Okay, the last question is question C, the time of flight of the rocket. Okay, time of flight. Put this one a little bit further up so that I can solve question C. So you have couples of method to solve this one. You want to find time, so you can measure the time over here. Okay, and then you can measure the time over here, and you can measure the time from maximum height straight to the ground. I think I'm going to do it in a new page instead, because this might take few steps. So I'm going to copy this one. Oops. Paste it over here. Okay. Now, you can do that like what I told you just now, or in another method, you can measure this time. You can multiply by 2 because the time will be the same, and then you can measure from there to there, and you add this time. So I think this one require a little bit more steps, so I'm going to stick with this is your T1, this is your T2, and this is your T3. So you're gonna have 3 separate time. Let's look at the information just now. They didn't give you any time before this, so again I'm gonna copy this one. Okay, and we're gonna start with T1 first. T1, they did give you the velocity, initial velocity, but you did find the final. So here is 448.58. Just rewrite it. Initial velocity is 35. Okay, so once you got this one, acceleration is given as well. E is equals to 5 meters per second squared. Okay, since you want to find the time, you can use the first equation there, VU80. So V equals to U minus 2G, minus GT. The final velocity is 448.58. Okay, U is equals to 35 minus 9.81. Sorry, this time the motor, the rocket still moving under the influence of the engine. Okay, so this one would be 5. So this one I got it wrong. It's not a free fall yet. This one should be plus. Almost got it wrong. So 448.58, get 82.72 seconds. So I repeat, for this part, okay, you still have the acceleration from the engine due to the engines, which is 5 meters per second square. So this is not a free fall yet. Okay, this is for your T1, label T1 to separate from others. Okay, the next part, we want to calculate T2. So we know that final velocity here is equals to 0. Now this one becomes the initial velocity. Again, you can use the same formula, but now it involves with, I'm going to change the color, but now you can use the free fall equation, okay, which is this one. So V is equals to 0, U equals to 448.58. Okay, this one is positive because it is pointing upwards. 9.81 and T. So 448.58 divided by negative. Okay, I think I somehow did this long method because you could actually finish up the calculation first. So I got here t is equals to 45.73 seconds. Okay, I double check the calculation is correct for now. Okay. Okay, the thing is, you can actually take this one as your starting position. You can straight away calculate this one as your final position. And I think I'm gonna do that because it's much simpler. So this method, if you want to continue, you basically have to calculate one more step, which is this one lah. So if you want to continue with this one, I think I'll continue with this one lah. Later on, maybe you can try it yourself. What if you put this one as your initial position and this one is your final position? But remember, final position you have to put the negative here. So that means since the height it travels over here is 20 kilometers, is it? Yes, 20 kilometer. So you can put this one as negative 20 km. Okay, you can try it yourself later on. And now I don't have the final velocity, but I do have the displacement, so I'm going to use that one. So I'm going to use s equals to u t minus half gt square. This one is free fall equation, so s would be negative 30.256, sorry, 30,256.07 equals to u is equals to 0 because it's from the maximum height. It's half 9.81 t square. Okay, the reason why I choose this number, it is actually represent the distance from here up until here. I put negative because I assume that this is my initial position, okay, which explains why my u is equals to 0. And yeah, that's all. So t is equals to, the negative will cancel out. The square root, I got 78.54 seconds. Okay, so I have t1, t2, and this is a t3. So if the question wanted to find the time of flight, you can simply add all this. So the total, I just put a total here, equals to t1 plus t2 plus t3, which is equals to 82.72 plus 45.73 plus 78.54. So the total here will be again, obviously there's a different method if you want to use that I told you before. You can try that one and maybe you can compare the answer. So this one, okay, the answer given is 207, which is correct. Okay, so I think that's all for this video.